problem states that a soccer ball is kicked from the ground at an angle of 30 degrees with speed 30 meters per second. Determine the duration of the flight, range, and maximal height of the trajectory. The very first thing I always do in these types of problems is draw a picture. So you see I got the y-axis and x-axis here. We know that it's an angle of 30 degrees. Oh, that was not a straight line, but you get the picture. Equals 30 degrees. We know that the magnitude of this vector here, this velocity vector, is 30 meters per second. We know that the trajectory is going to be parabolic, and it's going to reach its distance d at this point. It's going to reach a maximum height here when velocity in the y direction is 0. Alright, so now we have our image to kind of describe what's going on. The next thing I like to do is break down the velocity vector. So we know that it's 30 meters per second equals velocity, but it has an x and y component because of the angle. So to do this, use trigonometry. Sine of 30 degrees is equal to the opposite over the hypotenuse, which is 30. This simplifies to 30 sine of 30 equals the opposite, and we know that the sine of 30 is 1/2. So this becomes 30 times 1/2 is equal to 15 meters per second is your velocity y component. Now the same thing with the x component, just that we're going to use cosine as it's the adjacent side. So we'll simplify this to be 30 cosine 30 is equal to adjacent, or the velocity x component, which we know cosine of 30 is square root 3 over 2. So this simplifies to 15, 3 equals velocity in the x direction. So we're going to use calculus to solve this problem. We're going to parameterize this in 2 dimensions. So the initial point here is 0, 0. So we know the initial point 0, 0. We know the velocity. Hold on, let me just write this down. Point. We know that the velocity is represented in calculus by its x component, which is 15 root 3, y component 15. We know that there's acceleration. Even though this problem doesn't state it, we know that in a real world there's an acceleration on this force, and which makes it come down. Otherwise, it would just keep going off forever. So you have to account for the acceleration, which is known to be represented as such: 0 acceleration in the x direction, and a negative 10 meters per second squared in the y direction. You know, gravity is actually gravity is 9.8 meters per second squared. However, to make calculations simple, we're going to use negative 10. So now we can describe this line in full by stating r of t is equal to its initial point plus the velocity, 15 root 3, 15, plus its acceleration. And that's your position function. We know r prime of t can be represented as, in the x direction we have, well, t times 15 root 3 is just going to be 15 root 3, and t squared over 2 times 0 is 0, so there's no derivative there. In the y component, well, 0 t times 15, which is 15, and then this, when you take the derivative of this just becomes t, so t times negative 10, so you have negative 10t. Now we virtually have everything we need to solve this problem. When it reaches its max height, velocity in the y direction is going to be 0. So what you want to do is you want to set your velocity function in the y velocity function to 0 to find time. So 15 minus 10t is equal to 0. So you got negative 15 equals negative 10t. So t is going to be 3/2 at max height. To find max height, you're going to look into your position function and use the y components with the inputted value of t to find how high it went. Because we know y is the y-axis, it measures how high. So to do that, we are going to input 3 halves into our position function. 0, 0 plus 3 halves, 15 root 3, 15 plus 3 halves squared over 2, 0, and negative 10. Some calculations, we get the x component is equal to, well, 3 halves times 15 root 3 is just going to be 45 over 2, 45 root 3 over 2, and it's not going to have an x acceleration. In the y component, we got 45 over 2 plus, well, this is 9/4 over 2, which makes it 9/8, times negative 10, which is negative 98. When we can simplify this further by timesing this by 4 to get the 8. Well, 45 times 4 is 90, 180. 180 plus negative 90 is, so we have negative, or we have plus 98, which simplifies further to 45/4. And that is the height, the maximum height. We can now find, we can also find the duration of the flight. That would be our next step, by finding when y, the position of y, is equal to 0. So once again, we're going to use the y component of the position, find it when it's equal to, set it to equal to 0, and that will allow us to find the time, the duration of the flight. So let's see, we have 15t minus t squared over 2 times, let's see, it was negative 10, or it was 10, because I'm using the negative here. And we have to set that equal to 0. So the way we do this, let's simplify it first. Times 5 equals 0. Forgot my t. Take a t out. Now you can actually take a t and a 5 out. 3t minus t, whoops, that's not supposed to be a t there. 3 minus t is equal to 0. Well, we know that there's two ways that this representation can be 0. Whether when t is 0, 5t is 0, so this whole thing becomes 0. Or when t is 3 and this thing becomes 0. So we have t is equal to 0 or t is equal to 3 seconds. Obviously, time is equal to 0. We don't need that, as that represents this part of the graph. We need time is equal to 3, which represents this part. So time is equal to 3 seconds. That's the duration of the flight. That's the second component of our answer. And now we can plug t equals 3 into the x component to get the range. We have our x component here, which is represented by t times 15 root 3. There's no acceleration, so that's all we need to worry about. So t times 15, t times 15 root 3. We know t is equal to 3, so 3 times 15 root 3 equals 45 root 3 meters, which equals the range. And now we have solved all of the parts that the question asked. Another thing we can look at is the time of the maximum height was 3 halves. If you times that by 2, you get the maximum height times it by 2 is equal to the time of duration, which is 3. That's another way of checking yourself to make sure that the answers are correct, because It takes half the time to get up there and half the time to get down. So it looks like everything is proper. Thank you for watching.